Data can either be quantitative or qualitative. Categorical data are data which can be divided into distinct categories and can be either qualitative or quantitative. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, welcome to Statistics course with me, Aldino. In this video, we're going to learn about Introduction to Statistical Thinking. Statistical data has been recorded for most of the time civilization has existed. The Romans gathered a lot of information on the population, size, and wealth of nations in their empire. They usually carried out a census every 5 years, which required citizens to register their duties and property. This was then used to calculate taxes. Modern statistics, which attempts to do more than just record information, dates back to the 17th century. In this video, we are going to learn about two things. The first thing is to describe the role of statistics in modern society, as well as identify types of data, which is primary and secondary, categorical and numerical, discrete and continuous. First, what is statistics and why is it important? We live most of our lives relying on only partial information to make decisions. Some of the information we use is numerical. Other information can be summarized numerically. As we don't often have access to all the information when making decisions, statistics is largely about trying to make the best use of data we have at any given time. If we have a better understanding of the information we have available, this generally helps us to make better decisions because we have a better understanding of the risks involved. Consider the graph on the right, which shows the body temperature readings for 20 people. Each person has had their temperature taken with a mouse and an ear thermometer. Notice that for each person there are variations between the oral and tympanic readings, even though they claim to be testing the same value, which is body temperature. The next graph shows the temperature of the same 20 people, but now the gender of person is identified. We see that there is even more variability. It appears that males and females may have different body temperature characteristics. We are surrounded by variation, essentially the unpredictability of life. Statistics is a tool for helping us to make sense of partial information we have available and make more informed decisions. We already do this naturally and informally in many everyday situations. Consider the following examples involving uncertainty. The first example: the insurance industry is based on a business contract that is beneficial to both the individual and the company. Why do we have insurance? There are two main reasons. The first is it is good for us. A big loss may be unlikely to happen, but we couldn't afford it if it did. The second reason is it is good for the insurance companies. The large number of premiums they take in pay for the small number of claims made, which means they will make a profit. Although insurance involves uncertainty for both parties, statistics can be used to calculate the potential risk and rewards involved. The second example: an elevator should have a safety notice giving the number of people and the weight it is able to accommodate safely. How should the company who makes the elevator calculate this? The number of people allowed in the elevator one time is only a proxy for the important variable, which is the total weight. The company who makes the elevator will have assumed an average weight for each person. However, the weight could vary dramatically. The reality is that our mathematics of combining distributions depends on assumptions of independence, and we must keep the presence of variation in mind. Apart from the presence of variation, we need to be conscious that different contexts can tolerate different amounts of variation. For example, A newspaper does not need the same precision in printing as a banknote. There can be more variation in the manufacture of generic travel sickness tablets than of powerful chemotherapy drugs. And also, tragic consequences may follow if a change in quality of steel girders produced for use in bridges or large buildings is not immediately picked up and rectified. Next, we are going to talk about sampling. If you go to study master's degree or work with statistical later, you will encounter sampling theory. You have probably considered simple aspects of this already in your study of statistics. The need to avoid bias, for example. So, why do we use samples? Okay, the first is to save time and money. Often sampling will give us a large proportion of the total information for a fraction of the cost. Certainly, a lot of diminishing returns applies to increasing the sample size. It is often not possible to have complete information about a population, since some tests involve the destruction of the item. Testing may be very expensive. There just may not be time. The purpose for which the information is to be used influences how accurate we feel the information needs to be. Compare, for example, information which is needed to assess marketing strategy, to monitor health and safety. Consider the following situations. An airline has 243 passengers booked on the last flight of the day from Sydney to Seoul. If the airline has to cancel the flight, how many of those passengers will want to travel to Seoul the next day? How many people will the airline have to provide overnight accommodation for? It is not realistic to expect to know in advance exactly how many of the 243 passengers will want to travel the next day, or how many will want overnight accommodation. However, if the airline has some historical data on what has happened in similar circumstances on previous occasions, it can start making contingency plans. Many airlines now ask whether the passenger is traveling for business, to visit family, or for leisure when they book tickets. Probability distributions will help you understand what happens in these situations. A rare but very serious disease occurs in 1 in 10,000 people. There is a screening test which gives a positive result in 99% of cases where the subject has the disease, and gives a negative result in 99% of cases where the subject does not have the disease. How reasonable is it to tell a patient whose test comes back positive that they have this serious disease? Even though this screening test is extremely accurate for both of those with the disease and those without, for every person whose positive result occurred because they had the disease, there will be around 100 people who gave positive result without having the disease, because the disease is so rare. Conditional probability will help you understand what the implications of a positive result in a situation like this actually are. There is substantial evidence that shows that students in large classes in the UK have better examination results than students in small classes. Would it be reasonable for the UK government to decide that all students should be taught in large classes? In an effort to improve educational standards, this probably will not be a good idea. Schools put students who are more capable academically into larger classes, and their academic ability is the reason they get better results. This is an example where simply observing what is going on, instead of conducting a designed statistical experiment, could be very misleading. In the next chapter, we are going to talk about types of data. Data can either be quantitative or qualitative. Categorical data are data which can be divided into distinct categories and can be either qualitative or quantitative. The fruit on this trader's stall can be described by its properties. For example, the type of fruit the color, how ripe it is, these are qualitative data because this is not numerical, which is we can call it categorical data. On the other hand, the number of the type of fruit, the weight of a piece of fruit, the cost of fruit, these are quantitative data because this is numerical. You can count it. There are two types of quantitative data. Quantitative data can be either discrete, limited to particular values, or continuous, any value within a range. The number of pieces of fruit can only be one of a list of values. Could be 0, 1, 2, etc. For example, these 5 oranges on the right are an example of discrete data because you can count it. The weight of the oranges can be read from the scale as 1,400 grams. If you measure it more exactly, however, you might find it 1,369.2 grams. This is an example of continuous data. It will always be reported as a rounded value because everyone can measure it differently. The third example, what data about the radio are given in the advertisement. For each piece of data, state whether it is qualitative or quantitative, and if quantitative, whether it is discrete or continuous. You can pause the video and answer these questions. Okay, for the power, it's quantitative and continuous. For the wavebands, it's qualitative. For number of batteries needed, it's quantitative and discrete. For price, it's quantitative and discrete. For color, it's qualitative. And the last, length, width, and height, it's quantitative and continuous. For a large number of data observation, a list is not easy to make sense of. A frequency table of values can be used to summarize a large list. Sometimes it is helpful to use groups of values so the data are more easily understood. Let's go on to another example. A group of 45 women go on a skiing holiday. Summarize the following data in frequency tables. The number of children each woman has, you can see from the data shown in the video. From table, we can see that the number of children is listed as 0, 1, 2, 3, 4, and 5. And on the right is the frequency, which is the sum of number of children. 0 has 12 frequency. Number 1 is 21. Number 2 is 8. Number 3 is 3. Number 4 has 0 frequency, and the last one, number 5, it has 1 frequency. So from the data, we can conclude that 12 women have no children. The women's ages use class intervals of 15 to 19, 20 to 24, and etc. We can use 5 intervals. So from the data shown in the video, we can see that we can make a frequency table. As you can see, we can range it, we can list it from age 15 to 19, along the way to 45 to 49 with the frequency on the right. In this table, grouping the data sacrifices the detail, but allows you to get a sense of the distribution. Here is another example. Consider the marina at Monte Carlo. List at least 4 pieces of relevant data that might be collected. Include the type of the data and how it may be collected. Examples of data that could be collected for this situation include the numbers of boats in marina at any time, quantitative, discrete, and for each boat. The color is qualitative. The length is quantitative and continuous. The age of the boat in years is quantitative and discrete. The name is qualitative. The value is quantitative and discrete, though very many values are possible. The number of boats and color could simply be observed. The length could be measured, though perhaps only approximately if you can't get permission to board the boat. The age of the boat, however, might need side of a register not freely available, and the value can probably only be estimated by making comparisons with other similar boats solved in recent past. And Monte Carlo Marina probably has some boats in it for which there are very few comparable boats, making the estimate difficult. Color, name, and length are potential primary data examples, while the year of commission and the value are likely to be available as secondary data only. Now we are going to talk about primary data and secondary data. Primary data is any data which you collect yourself. It may be measurements, but can also be through questionnaires or other surveys, investigations, and experiments which you collect yourself. Secondary data has been collected by someone other than the person using the data, which may be in the form of the raw data, but it also includes databases, published statistics, newspapers, etc. The internet has a huge amount of secondary data freely available for people to access. For example, national statistics, but also data from organizations such as the Guinness Book of Records are available online. With secondary data, it's important to know that it was collected reliably and that the data matches what you want to investigate. If it does not have all the information you need, you will not be able to use it. However, when it is available, secondary data saves a lot of time and effort. A lot of data is now collected automatically using some form of technology. You can call it as scraping data or crawling data. This is another example. Amir is concerned about the traffic passing his house. One morning, he spends an hour counting the cars that pass his house. He then hears that the council has installed a sensor which automatically registers when a car goes past. Amir gets a summary of the traffic in the past 6 months from the council. The first set of the data described is primary because Amir collected himself. The second set is secondary data because it was collected by someone else, which is the council, in a data logging process. To sum it up, this is the summary of what we have learned. Data can either be quantitative or qualitative. Quantitative data is numerical in kind. Qualitative data is non-numerical in kind. Quantitative data can either be discrete, limited to particular values, or continuous, any value within a range. A frequency table of values can be used to summarize a large number of data observations. Groups of values may be used so the data are more easily understood. That's all for the materials, and don't forget to subscribe to the Teknokrat channel as well as like this video, and also don't forget to drop the comments below. I'm Aldino, see you in the next video. Wassalamualaikum warahmatullahi wabarakatuh.
Terima kasih sudah menyaksikan video pembelajaran ini. Jangan lupa like, komen dan subscribe, serta nyalakan tanda loncengnya agar kalian tidak ketinggalan informasi update lainnya.